Hello my scholars, welcome to my school channel. We'll be tackling the 2019 JAMB past question for physics. We'll be solving the question number 81 to question 104. So join me as we provide a step-by-step solution to each of these questions. And don't forget to click on the subscription button below so that you can get informed as we release the next videos. So join me as we tackle question number 81. A safety precaution designed to prolong the life of a lead acid accumulator is what? So we should know that topping the cell with conch acid is wrong, because already in the lead acid accumulator it contains acid and distilled water. So if you want to top it up, you top it up with water, distilled water to be precise. So option A is wrong. Option B, the use of naked flame should be avoided when charging the battery. So option B is out. Option C, let's examine it together. Keeping the specific gravity of the electrolyte within specified range. This is very important because for a fully charged lead acid accumulator, it's about 1.26 or 27 when you use hydrometer to measure the specific gravity of the electrolyte. When it is discharged, it's around 1.097 thereabouts. So it's important for you to keep the specific gravity of the electrolyte within specified range. So without further ado, option C is very correct. Here we have question 82. The mass of water vapor in a given volume of air is 0.05 grams at 20 degrees Celsius, while the mass of water vapor required to saturate it at the same temperature is 0.15 gram. Calculate the relative humidity of the air. This is a very simple question to tackle as usual, okay? So relative humidity rather equals the amount of water vapor present in air, okay, which is giving us 0.05 divides the amount of water vapor required to saturate it, and which is giving us 0.15, okay, times 100%. This is very easy to solve, okay? So this is year 1, year 3. Or if you would like to make it more simpler, you like me to break it down for you, we can do something like this. This is 0.05 divides 0.15 times 100. So this means 5 over 100. So this is 5 over 100 divided by 15 over 100 times 100 over 1. Okay, so we have 5 over 100 times 100 over 15 times 100 over 1. Okay, so strikes out 5 here 1, 5 here 3. 100 divided by 3, that should give you 33.33333%. So join me as we scan through our options and see which one is correct. So definitely option C is very correct. On to question 83. The angular dispersion of a prism depends on what? This depends on the index of refraction, because white light in a vacuum, they can travel at the same speed, but on getting to a more thicker medium like a glass, okay, like a glass prism, at first their wavelengths will be different, okay, the speed at which they will travel will be different, and it depends on the colors of light that will be dispersed through the glass prism. So it is the index of their refraction only. So option A is correct. So don't forget that you can get the Myschool mobile app or purchase the Myschool software using the links in the description below that will take you directly to the Myschool website, where further instructions and guidance will be given to you, so you can increase confidence and your competence in your coming exams. So join me as we tackle question number 84. Which of the following statements are correct of the production and propagation of waves? Statement 1, vibration produces waves. This is very correct. Statement 2, waves transmit energy along the medium. This is correct from the definition of wave. The medium through which the wave travels does not travel with the wave. This is very correct. Statement 4, waves do not require any medium for transmission. This statement is partially correct because certain kinds of wave require material medium, like for instance your sound wave. The ones that do not require a material medium, for instance electromagnetic wave, like the radiation from the sun, does not require a medium. So this statement is partially true and partially incorrect. So we have to strike out statement 4. That makes statement 1, 2, 3 correct. So option D is very correct. So do not forget to hit the like button, click on the subscribe button and tap on bell notifications so you can just get informed as we release the next videos. Now to question 85. A rectangular solid block has length 10 cm, breadth 5 cm and height 2 cm. If it lies on a horizontal surface and has density 100 kg per meter cube, calculate the pressure it exerts on the surface. So recall the formula that pressure equals force over area, where force is mass times gravity over area, where mass is density times volume times gravity over area, where volume is length times width times height times gravity over area, where area is length times width. So length strikes out length, width strikes out width. So we have density times height times gravity. So where density is 100 times the height is 2 cm, bringing it to meters, it becomes 0.02 times gravity 10. So this will give you 100 times 0.02 will give you 2. 2 times 10, that is 20. So going through our options together, option A is correct, 20 Newton per meter squared. Here we have question number 86. Okay, look at the diagram. The diagram shows 4 positions of the bulb, a pendulum bulb. At which of these positions does the bulb have maximum kinetic energy and minimum potential energy? Okay, so at this point here, we'll assume that this is the farthest point that the bulb swings to. So at this point, the potential energy is maximum and there are no kinetic energy at this point 1 and 4. Okay, so at 2 and 3, we will see that the kinetic energy is equals to the potential energy. So 2 and 3, KE equals to PE. But for the question we have before us, it requires that where the maximum kinetic energy is, where there is maximum KE and minimum PE. So this should have been the point, this line that is perpendicular, okay, to this angle here. So this should have been where the KE is maximum and the PE is 0. And the point is not there in the diagram. So none of the above is the answer. So option C is very correct. Question 87. An object is acted upon by a system of parallel forces, causing the object to be in states of equilibrium. Which of the following statements is not correct? Is not correct. Okay, so let's look at option A. The resultant of the parallel forces is 0. It must be 0. Option B. The algebraic sum of all the moments of the forces is 0. This is very important too. Of the moments of the forces, they must be 0. The parallel forces, their resultants or their sums must be equal to 0. Option C. all the parallel forces must not be equal in magnitude and direction. This statement is not correct because for a parallel force to be in equilibrium, to cause the object to be in equilibrium, it must be equal in magnitude or size, okay, and direction. So let's see option D. The sum of the forces in one direction must be equal to the sum of the forces in the opposite direction. This is equally important. Either the upward force must be equal to the downward force, the rightward force must be equal to the leftward force. Okay, so option D, B, and A are correct, but option C is not correct. So that makes option C the fitting answer for question number 87. As you've been following the video tutorials and you have one or two questions you'd like to ask, with the link I've provided in the description below, you can ask those questions right now, leading you to the Myschool website where several solution providers are waiting just for you to provide you clarity and solutions to any of the questions you have to ask. So join me as we tackle question number 88. Which of the following statements is/are correct for a free falling body? Okay, so the total is entirely kinetic. This is wrong because as a body falls, the decreasing potential energy is equal to the increasing kinetic energy. So statement 1 is out of it. Statement Roman figure 2, the ratio of the potential energy to kinetic energy is constant. No, that is not the total energy definition. Total energy definition is the sum of the potential and kinetic energy, which is constant. That makes statement Roman figure 3 correct. The sum of the potential and kinetic energy is constant. So option C is very correct. Perhaps you have better explanations to any of the questions we have solved so far in these video clips. Please, I would like to know as you share this suggestion or explanation with us. You can do this by indicating the question number and the solution you would like to share in the comment section below. Question 89. Efficiency of conduction in liquids and gases compared to solids is what? If you just look at it, it's less efficient because in solids, conductions are usually faster and easier because at first, the atoms or the molecules of solids, they are closely packed together in a fixed positions, okay, which allow for easy movement or transfer of kinetic energy and the vibration of these molecules, okay. So definitely conduction in liquids and gases when compared to solids, they are less efficient. And to note this, that conduction in liquids is more efficient compared to in gases, because for conduction to happen in gases, especially of electricity or electric currents, you have to lower the pressure and increase the amount of voltage that passes through it. That is just for side information. So basically to the question we have been asked, they are less efficient compared to solids. So option A is very correct. Down to question number 90. A well 1 kilometer deep is filled with a liquid of density 950 kilogram per meter cube and acceleration due to gravity is 10 meter per second square. The pressure at the bottom of the well is what? Okay, so that just means we have to pull in one or two formulas together. Remember that the formula for pressure equals force over area, isn't it? And recall that force is mass times acceleration due to gravity in this sense, okay, over the area we still have left here. And when you recall that density equals mass over volume, so to find mass, that will be density times volume equals mass. So that means we are replacing mass with density times volume. So we have density times volume, okay, which is replacing mass times gravity over acceleration. Over area rather. A for area. Okay, so recall that. So that means we have pressure will be equals to, just follow me, pressure will be equals to density times the volume. Formula for volume is length times width, okay, times height, or length times breadth times height. And area is length times breadth, or length times width. So we have this times the gravity over area, length times width. So length strikes out length, width strikes out width. So we'd have pressure equals density times the height times gravity. Okay, so having gotten this, recall that we are also dealing with the constant density, which is density of water. Okay, and density of water is 100, isn't it? So if we convert this 100 kilogram, okay, to gram, what we would have is 1.0, okay, times 10 raised to power 5, okay, because 100 times kilo is 1000, so 100 times 1000 will give you this. Okay, very well. So we'd have our density from the question is 950, okay, times the height is 1 kilometer deep, so that is 1 times 1000, and that still gives you 1000, okay, times acceleration due to gravity, which is 10, plus this, okay, because from 100 times 1000, that gives you 100,000, and this is 100,000 we represent in standard form. So okay, if we multiply all of this together, this is 1, 2, 3, 4, 5, okay, so we'd have 95 times 10 raised to power 5, okay, plus 1.0 times 10 raised to power 5. 95 plus 1, that gives you 96, okay, times, we just have 10 raised to power 5, okay, or you can say 9.6 times 10 raised to power 6. Since we shifted the decimal, okay, it will have a corresponding increase in the exponential power here. Okay, so let's go through our options together and see which of them is correct. So option A is correct. Question 91. Sum of all forces acting on a body is 0. This condition represents equilibrium. What condition of equilibrium does it represent? It represents the first condition of equilibrium, which means that sum of all the forces acting on a body that is not accelerating, is equal to 0. The net force and the net torque, okay, is equal to 0. So this condition represents the first condition of equilibrium. So option A is very correct. Question 92. Okay, consider the diagrams here. Which of the following bodies, each with center of gravity G, lying on a horizontal table, is or are in unstable equilibrium? Okay, so objects 1 and 2, they are in neutral equilibrium because it's until you apply a level of displacement on them, that is when they will move, okay? That's when you will see them topple or move. Okay, so objects 1 and 2, they are in neutral equilibrium. Looking at object 3, you can see that the center of gravity is very low. So any displacement will make it to topple and move away from its equilibrium position. That shows that it is unstable. So object 3 is unstable. Let's look at object 4. You can see that the center of gravity is very high. So even when you apply some level of displacement to it, it still comes back or return back to its equilibrium position. So this shows a stable equilibrium. So only object 3 is in its unstable equilibrium or is in unstable equilibrium. So that makes option B very correct. Question 93. The volume of a stone having an irregular shape can be determined using what? You can use the water displacement technique, okay? You fill in your measuring cylinder with some level of water, some quantity of water. You measure the initial volume. By the time you deposit this stone into the measuring cylinder, okay, the amount of water displaced or pushed up across the calibration of your measuring cylinder, that water displaced tells you the volume of the stone that has a irregular shape that you are trying to determine. So you can determine the volume of a stone having a regular shape using measuring cylinder in the water displacement technique. So option B is very correct. So do not forget that you just have to get the Myschool mobile app or the Myschool software so you can practice ahead of your coming exams. With the links I have provided you in the description below, you can access the Myschool mobile app or the Myschool software through the Myschool website. So just click on the link. You'll be taken straight to our Myschool website, and from there you get further instructions on how to purchase any of these tools to enhance your performance. Okay, so join me as we tackle question number 94. In sunlight, a blue flower looks blue because we see the flower by the light it reflects. Okay, so the flower absorbs light from the sun. The light that it doesn't absorb from the sun, it's what is reflected back to us that we see. So this flower here reflects the blue light to us, and that is what we see, and that is why we see the flower as blue. So basically the correct option to this question is option D. So don't forget to hit the like button, click on the subscribe button, and tap on bell notifications so you can always get informed as we release the next videos. Question 95. A body moves in simple harmonic motion between 2 points 20 meters on the straight line joining the point. Okay, so that means between 2 points, that is 10 meters, 10 meters. Okay, so if the angular speed of the body is 5 radian per second, okay, calculate its speed when it is 6 meters from the center of the motion. So recall that the velocity of an object oscillating with simple harmonic motion, it varies directly with displacement x. So V varies directly with displacement x. And in this question, we talked about the angular velocity. This is a replacement for angular velocity. So this equation represents the relationship between velocity and the displacement. Okay, so now let's plot in our values. This is very easy to do. So V equals our angular velocity, which is given as 5. Okay, remember the angular velocity is just displacement against time. Okay, then we have multiplies this is A, our amplitude, and we are given the amplitude as we're having 20, and I told you that we have 20 between 2 points. That makes it 10 apart. So that will be 10 squared minus the displacement x. We are given our displacement as 6 meters from the center of the motion. Okay, so V equals 5, 10 squared, that is 100, minus 36. Okay, that will be V equals 5 times square root of 64. Okay, so that implies 5 times 8, and V equals 40 meter per second. Okay, so the speed when it is 6 meters from the center of the motion is 40 meters per second. So that makes option C very correct. Question 96. Okay, look at the diagram we have before us. The diagram shows a uniform meter rule AB, okay, which balances horizontally at 90 centimeter mark. Why? Because a mass of 0.2 kilogram is being hung from B. All right, so calculate the mass of the meter rule. This is very easy to calculate. Okay, so just recall to the other sides, or to the either sides of the meter rule, why it's able to balance. So at this side, you realize that we have an unknown mass, okay, multiplied by where the pivot is being placed, okay, which is 90 from the center of the meter rule, okay, equals the mass at point B, which is 0.2, multiplied by where B is being placed, which is 100, from the pivot point, which is 90. Very easy to solve. So we have m times 90 minus 50, that is 40. So m times 40 equals 0.2 times 100 minus 90, that is 10. Okay, so we have m times 40 equals 2. So dividing both sides by 40, 2 here 1, 2 here 20. Okay, so 1 over 20 is 0.05. We're measuring mass, that is in kilogram. So let's go through our options together. Option A is correct. So the mass of the meter rule is 0.05 kilograms. Option A. We have question number 97 right before us. Okay, so the equilibrium position of objects in any field corresponds to situation of what? Just take for instance your pendulum bulb. Okay, it is just at the point where it is, just that direction is perpendicular, okay, to where it's being hung from, something like this. So just at that center, you realize that the kinetic energy at that point is at the maximum and the potential energy is at the minimum, and that shows you a kind of equilibrium or stability, as you may refer to it. So if we're going to scan through all of these options, equipotential talks about a kind of field whereby all the points, okay, on the particle or the object, they carry equal potential, equal amount of potential, and that talks about an electrical field basically. So maximum potential energy, if I'm still going to use a pendulum bulb, when the potential energy is maximum, you will see that it's being tilted to the extreme left or to the extreme right. You still realize that the object is not yet balanced, it still oscillates. So this is out. So definitely option C, minimum potential energy. Okay, where the force is 0 multiplied by the distance. Okay, so that gives us that option C is correct. In this situation, minimum potential energy corresponds to the equilibrium position of objects in any field. Option C. So do not forget that there are several solution providers on the Myschool website waiting for you to ask your questions and gain clarity within moments. You can use the link I have provided in the description below to reach the Myschool website where you can get the necessary help. So join me as we tackle question number 98. The height at which the atmosphere ceases to exist is about 80 kilometers. If the atmospheric pressure on the ground level is 760 millimeter mercury, the pressure at a height of 20 kilometers above the ground level is what? Okay, so recall the formula of pressure, which is force over area, where force is mass times acceleration due to gravity. We still have the area underneath, okay, where mass equals density times volume times the gravity over area. Okay, let's proceed. We're trying to derive our dimensions here. So we have density multiplies volume, where volume is length times width times height, or length times breadth times height, times gravity over area. Area is length times breadth or length times width. So length strikes out length, width strikes out width. So we are left with pressure equals density times height times acceleration due to gravity. So we have density, we have the pressure of both sides to work on. So we'd have for this side, for the left hand side, density times height times gravity equals density times height times gravity. Okay, so from the question we are provided with the value of density as 13.6. So we'd have 13.6. So comparing the atmospheric pressure at the ground level and above the ground level, so that will be 760 minus the pressure above the ground level. Remember, in millimeter mercury, that makes 10 raised to power minus 3 equals, to the other side we have the density is given as 0.00013. Bringing that to standard form, that makes 13 times 10 raised to power minus 5 times our height, 20 kilometers, that is 20 times 1000, or 20 times 10 raised to power 3. Okay, so what do we do next? We divide both sides by the coefficient of 760 minus p equals what we have on the right hand side, which is 13 times 10 raised to power minus 5 times 20 times 10 raised to power 3 over what we are dividing both sides with, which is 13.6 times 10 raised to power minus 3. 13 times 20, that gives us 760. That gives us 260 rather. 260 times 10 raised to power minus 5 times 10 raised to power 3. That is minus 5 plus 3. That gives you 10 raised to power minus 2 over. We have 13.6 times 10 raised to power minus 3. Minus 2 minus 3, that gives you plus 1. 260 divides 13.6 times 10 raised to power 1. Okay, so when we divide this, we would have 760 minus p equals, when we divide this, we will have 19.12 approximately times 10. That should give us 191.2. So if we make p the subject of the formula, so we would have 760 minus 191.2 equals p. When we do our subtraction, we would have 568. If you want to approximate, that can make it 570 equals p. So the unit is millimeter mercury. So the pressure above the ground is 570 millimeter mercury. So let's go through our options together. Option B is correct. Perhaps we have a better explanation to any of the questions we have solved so far. You can indicate this in the comment section below by indicating the number and the solutions you would like to share. Question 99. A cone is in unstable equilibrium. Has its potential energy increased? This is because the position has been identified as unstable, shows that any application of force will cause a further movement of the cone. So this amplifies or resonates with the phenomenon that a cone in its unstable equilibrium has its potential energy increased due to its position. Question 100. A mass of 0.5 kilogram is whirled in a vertical circle of radius 2 meters at a steady rate of 2 revolutions per second. Calculate the centripetal force. From our formula, we recall that centripetal force F equals the mass times velocity square over radius. Okay, where velocity equals angular velocity multiplied by radius, where angular velocity is 2 pi f, which is frequency, times r. Okay, so from the question we are given our frequency as 2 revolutions per second. So 2 times 2, we have 4. So we have our velocity equals 4 pi r. So let's slot it into the equation, which is the formula for centripetal force. So F equals the mass. We are given the mass as 0.5 kg multiplied by the velocity square divided by the radius r. So once we expand our brackets, we have 0.5 times, this is 4 times 4, that is 16, times pi square times r square divided by r. So r strikes out the square, so we would have 0.5 times 16 times pi square. Then we are given the radius of 2 meters. So multiplying this, we would have 0.5 times 32 times pi square. By the time we multiply these values we have here, we would have 157.75 with other values attached to it. So we can approximate this to give us 158 newtons. That's the unit for force. So going through our options together, we'll see that option C is absolutely correct. Question 101. A body was slightly displaced from its equilibrium position. Which one of the following is a condition for its stable equilibrium? An increase in the potential energy of the body. This is because when the body is at equilibrium, a slight displacement will cause an increase in the potential energy. So, for it to come back to its equilibrium position, this will be an effect that is responsive to the increase that we have in the potential energy. So, the potential energy lost equals the kinetic energy gained. So, option B is definitely correct. An increase in the potential energy of the body is a condition for its stable equilibrium. So we have question 102. Which of the following readings cannot be determined with a meter rule? Okay, the meter rule has a measurement accuracy of 1 millimeter or 0.1 centimeter. It's also possible for you to approximate half of its millimeter, which is 0.5, or if you are converting it to centimeter, which is 0.05 centimeters. So of these options that we have here, what cannot be determined with a meter rule is 2.56 centimeters. So option A is very correct. Down to question 103. Which of the following is consistent with Charles' law? Recall that Charles' law implicates that volume varies directly with temperature. Okay, so looking at the first graph we have here, we have volume plotted against temperature, not inverse of temperature. If you consider the second graph, we have volume plotted against inverse of temperature in Kelvin. The third and the fourth graphs cannot be used because it should begin from the origin. Although it can extend from there, but it should pass through the origin. So between graph 1 and graph 2, we will go for graph 1 because it is plotted volume against temperature, not inverse of temperature. So graph 1 is consistent with Charles' law. That makes option A very correct. So that is it for this segment, but there is definitely more to come. I know you enjoy this sort of content and you would like me to bring you more of them. So don't forget to hit the like button, click on the subscribe button and tap on bell notifications so you can get informed as we release the next video clips.